Everyone. Hello everyone. In this video we have to see about the lecture videos on point group and space group. So now the previous class, continuation of the previous class, we have to see about the atomic orientation of that different atomic in the crystals, that is called as point group and space groups. So we can see the translation, that is the translation symmetry of the operator moves object by the displacement, or it is called as a displacement around the orientation. So you can see that the picture is exactly denoted that is the atomic position of the atoms. We can say the external shape will be differed. So if the atom has the right hand palm is known as the atomic position or atomic orientation, or group of molecule orientation. It will be translated by the B2, that is the unit length will be translated, and the axis, that is called as a B axis. So and also it is as a reflected. So that is the divided by the point. So it will be translated to the T, and again along the axis it will be rotated to the opposite side. That is a reflection mirror present on that. So it is called as a translation. And another thing, we will differ. So translation with mirror orientation is called as a space group. That is the movement of, that is the atomic orientations. Crystals cannot move, but it will be oriented different orientation according to the symmetrical point. So there is an atom, we cannot control the atoms to sit there and there. So it will be naturally occurring. We can classify that orientation of the molecule according to 230 space group, according to the translation and mirror symmetry. We classified. So what are the material will be present in the world? Only 230 type of the phase groups orientation or structure will be possible to occupy. Every atom, any group of molecule only possible to accommodate in this 230 space group according to this classified 230 space groups. We have studied according to this translation and symmetry operation. We have classified and confined the structure orientation of the atomic molecules in the 230 types of the structure, that is called as the space groups. So that is a periodic way of objects, that is size, position, the standard symmetry. The pattern inscribed describing the entire pattern we cannot split, and repeated unit will be translation vector. That is the repeated unit. For the general we have to go called as a it is called as a point space group, and we will call as a unit cell. Then once point group and space group decided, then will we go for the construction of the unit cell. So that is the fundamental building block. This is the example of the molecular orientation, how it is classified. You can see that the images which indicate that it is two height, that is a molecule. So it is center of symmetry through the eye. Center of symmetry, it is nothing but reflection to the center, that is inversion center, that is called eye. You can see the top atom and molecule atom dotted line through the center of the axis, it will reflected another area. So next we have the mirror plane at horizontal we can send the square line, that is known as the it will reflected to the another same of the mirror. So it has a mirror symmetry, that is also rotation symmetry. So mirror reflection and rotation, it is joined together, and we have to identify the position of the atom according to the symmetry operation elements. So that is the first one. So next one is the how much is formulation, for how much we have to calculate the formula for the transition. It will be called by n by t. This is a translation and will be classified. This is the orientation of mirror rotation according to the, and also the rotation about the one axis. So it will be rotated, and different type of molecules, different orientation will be classified by these rotation and symmetry angles. So these are different atoms and classified by the sorry. So different atom in the crystal we have to classified according to the symmetry elements and graphical notations. So glide plane is nothing but the including reflection and translation, and double glide plane is nothing but the two times of the displacement will be along the one glide plane, one axis, and in addition to the reflection mirror. So that is called as a glide plane. So our next one is the glide diamond plane. So this glide plane is along the 1/4 of the axis, that is the lattice parameter having the a means it has half of the angle, means it has half of the distance we can translate. So indicate these are the main different glides translation planes are available in the crystal structure. These are the right left top, you can see the different type of symbols we have, nomenclature we have used for the identification and classification of the crystalline point groups of the projections. So it will be indicated the how much is how much that electron will be moved. Electrons, so atoms can move according to the origin of. We have the origin, we have this imaginary origin. According to that, we have to how much atoms and groups we have moved in particular direction. We have to use the nomenclature of the symbols to indicate these symmetry elements and symmetry groups are present in the crystalline materials. So in this class we have stopped here. Next class we in this video we have seen that atomic point groups. Point groups is how much is space groups were classified by this previous table. So now we can see that easily you can identify that this is a unit cell. How these atom positions will be identified by this symmetry operations. So you can see this a group of molecules surrounded the drawn unit cell. Unit cell is the fundamental building block. According to the unit cell, the atomic position will be classified according to corresponding their symmetry element present in the crystals. So this is a pictorial diagram and about the symmetry operation, that is the dot images shows the center of images and the square around the unit cell called as the mirror images, and the screw axis, that is the column type indicate column type marks, and red and black is indicate the screw translation about the atoms on the crystal unit, that is space group called as PG. So this is the exact position of atoms will be situated in the crystal structure. So these are the pictorial examination of the space group and spine group. This will be classified into that 14 types of Bravais states and 230 space group. These are the classification, and corresponding unit cell will be correspondingly called as a crystal systems. So in this video we have stopped here. Next video we have seen about the crystals and X-rays. These are the main group relation between the Bravais lattice and space groups and point groups. Thank you.